Hello, everybody. Welcome back to the episode. So, in this episode, I'm thinking to record a little bit longer so people don't need to watch multiple episodes here. We are going to cover the sun and the related phenomena, whichever you see here, till the planets. This will be a little bit longer, but it will be elaborative and you can understand better. So here we are going to start with the sun. If you didn't watch the solar system episode, definitely do watch. You will get a recap of everything. If you know it is fine, but still if you watch then you will get a recap. So basically the theory of the sun is it is a star. It is the central celestial body. This central celestial body is at the center and our planets will rotate around it. That is what the sun is. Our sun is 5 billion years old. Universe is 14.7 and our sun is 5 billion years old. How it is formed? Because of supernova. It is already explained intensively in the previous episode, so please watch that. Hydrogen and helium is what the sun consists of, and there is conversion of hydrogen and helium, and the nuclear radiation will be sent out. So whatever we are getting is solar radiation. That is solar radiation we are getting. So now we are going into the inner section of the sun here. What is inner section of the sun? I want to explain in detail that what happens at every level of the sun. Basically, the inner section of sun is liquid in nature. Liquid inner section, the inner core is liquid in nature and it is surrounded by the gaseous outer core. You understand this? We will get deep into the layers also. Here the layers of sun we will cover in a minute. But the inner liquid section, whatever it is there, it is covered with the gaseous outer section. So diameter and all you can see on the screen itself. I hope so. Here 13,92,000 kilometers of diameter, 15 million degrees Celsius, which is liquid core, and then 5500 degrees Celsius at the surface because this is gas. That is what the temperature of sun differs from. Let's jump into the main topics or the real topics which we have to study, that is layers of sun. So in the beginning itself I want to classify. There are 7 layers. Basically few layers are just transition layers which I'll show you here. These transition layers are uh, important. You have to mention them, but they basically work as transition layers. First three are called inner layers because they are from the core. This is from the core to the outside corona. So core, and the outer one is called corona. So this corona and the core, we are going to talk about multiple layers. So including these two, we have 7 layers. These 7 layers, the first 3 layers which you see here are inner layers. The first layer is called the core. This is basically the central region and it is the hottest part of the sun. As I have told you before, it is around 15 million degrees centigrade, 15 million degrees Celsius. So this part where hydrogen is converted to helium in our solar system. In our solar system, the core is the only part where hydrogen converts to helium. If there is some other part, then that becomes one more star and sun. That is the main process happening at the core of the sun. When this cuts down, then our sun starts to collapse due to gravity. We have already talked about that in the supernova situation or white dwarf, black dwarf in the previous episode. Then now there is a radiative zone, which is a transition zone, as I told you. Basically, energy transfers using photons from core to from core to outer layers. That is called the radiation zone, radiative zone. If we have the sun's internal photo or something, just put it aside and then watch this particular section in the video. You will get more clarity. So this radiative zone, basically radiative means it is radiating through convection. What is convection? Movement of particles. Here see, convection, which is radiation. So this convection will move the photons from the core to the next level. That is what the transition zone I was talking about, that is radiative zone. And then we have convection, where the plasma, the hydrogen and helium plasma, whichever it is there, this is very much important because this plasma comes out sometimes. We are going to talk about that in this video. This plasma, I am concentrating the word plasma here, referring the ionized helium and hydrogen particles, like hot air to surface. This is where the convection happens. Even this is a transition zone. Now the surface, outer layers, the surface is called photosphere. This photosphere is solar surface where photons emit. Whatever we see in the sun, it is the photosphere. But where the photons originate or come from the core, it is radiative zone. The radiative zone is where the photons from the core through convection will be transferred to our particular photosphere. And then we have chromosphere. It lies above 2100 kilometers. It is like atmosphere around the earth. We are going to talk like that. Photosphere is the base surface of the sun, and core is internal surface. Then we have the convection, and then radiative zone which radiates, and then the convection, and then the photosphere, and then we have chromosphere, which is 21 kilometers height above the sun, more like an atmosphere to the earth, to be in simple terms. There the 3700 to 7700 degrees centigrade, because the core is far away from the chromosphere. In the transition region, we have chromosphere to corona transition. Corona is the outermost layer of sun, where the temperature is 500,000 centigrade. This cannot be seen with the naked eye, but in solar eclipse, when you see the sun is covered by moon or the shadow of earth, when in the solar eclipse, the shadow of earth or the moon covers it. So the outer part, whatever you see, this part is basically our outermost part, which is corona. So now either the shadow of the earth falls on moon, the lunar eclipse, or the moon covers the sun, the solar eclipse. This time you can see the corona. That time you can see the corona. That is what happens in the last zone of corona, last zone of the sun. This is what happens. So photons come from the radiative zone, will be transferred to photosphere, and then this photons will be emitted, which is what we look at. But corona can't be seen, and corona can be seen during only solar eclipse. When the moon covers the sun, there will be a circle outside, that is called corona. Now we are going to know more things about sun. What are sunspots, multiple terms, and then close this episode. We're going to talk about planets in the next episode. So let's do sunspots. Sunspots are cooler surroundings, cooler than surroundings. For example, there exists, and I'll take a pen and tell you. For example, there exists some kind of a sun here, and then what happens is these are solar spots. These are not fixed anytime. These are like, there will be a magnet inside sun. For example, I am drawing a bar magnet here. Don't take it in literal sense. General example sense. Okay. Now this magnet Here the field is strong. Here the field is strong, consider. Here the field is weak. Wherever the magnetic field is so strong, then that place will be a little bit cooler compared to its surrounding. Cooler means not minus degrees or snowfall. Cooler means if it is millions degrees centigrade, then that place will be million minus 1 degree centigrade. That is what cooler than surroundings mean. So now what happens here is these areas are magnetically so strong. These areas are magnetically so strong. Then the sunspots occur there. Why these occur and all we are going to talk about in the magnetic thing. We'll talk about that. But this is how sunspots occur. And this magnet which I talked about will change when it is north south here. It will change south north every 11 years in the sun. It will change every 11 years. That is what called as solar cycle. That is called as solar cycle. Every 11 years they will come back. Now we are going to talk about solar wind. So, as I told you before, there is a plasma here. Plasma from the convection layer. Here plasma, which is ionized hydrogen and helium, sometimes will be thrown out. Will be thrown out because sun's gravity cannot withhold it anymore. So this particular plasma is thrown out radially outward. You see here how dangerous it is. It is not like how we discuss it simply. Out of sun's corona, there is sun's plasma coming out. That is called solar wind, and this happens many times. So this is called solar wind. We'll talk about the effects and all. We'll talk about very soon. Solar flare is something extreme explosion happened on the sun when electromagnetic energy formed on sun is suddenly released. As I told you before, there are four fundamental forces in the universe when the universe is formed: weak nuclear force, strong nuclear force, gravitational force, electromagnetic force. Electromagnetic energy is formed because of moving electrons or charges. So when this is formed on the sun's surface and that the sun surface is suddenly released, and also solar flares, as I told you here, solar flares will also accompany these solar ejection, whatever the ejection it is there, I mean electromagnetic energy, and then the solar flare will be accompanied, and that is called, from corona it will start, so it is called coronal mass ejection. That is called coronal mass ejection. So this plasma we were talking about here in the sun, in the solar wind, we are talking about the plasma. This plasma and magnetic field from sun's corona will affect on the solar flare. If there is huge magnetic field, there is high chance that that particular solar flare will be less from that region. So sun's magnetic field and sun's solar spots, whichever we have seen here, solar spots affect heavily from where the solar flare or the coronal mass ejection happen. So now we are going to talk about an optical phenomenon. Basically, it is optical phenomenon, happens on Earth and might happen, might not happen on other planets, which is called sun halo. So this halo you see here, as I told you in the previous videos also, this halo whichever you see here is called sun's halo. So basically, millions of ice crystals suspended in the atmosphere. This is a 22-degree circular halo. So a rainbow colored ring will be formed around sun or moon with 22-degree radius. This is called 22-degree halo, which happened very much recently in Bangalore. So this happens when there are cirrus type of clouds. Basically, cirrus are like hair-like clouds basically formed in the sky. We'll talk about cirrus clouds in the climatology topics. Cirrus clouds is also, it is very you can get them very easily whenever there are like floating clouds like this, hair type of, not that thick and dense. They'll be like cotton. They are cirrus clouds. Those cirrus clouds, when they are very thin, that time there is a high chance of happening a solar halo. This is what a solar halo is. And then we are going to talk about solar minimum. Basically, solar minimum is when sunspots are not virtually visible at all. Solar minimum means the sunspots are very low. Sunspots are very low. And maximum means same thing. Sunspots are very high. So this changes every 11 years. That is what the solar minimum and solar maximum is about. When sun have more spots, then there is very less chance of coronal mass ejection or the solar flares to erupt. Then we get auroras. If uh, if sun sends more electrified gas or plasma into the space, we get more auroras. And sometimes that plasma also affects our satellites, sometimes GPS, and also many other communication issues we will face, power grid issues also we will face. This is the major problem with the solar flares. So fewer sunspots, uh, if you have more sunspots, then you will find very less solar flare occurrence. If there are very high sunspots, then very less. If there are low sunspots, then there will be very high chance of solar sun flares. They will change every 11 years. So Alfvén Critical Surface, it is outer edge of the corona. You can read the remaining thing from here from taking a screenshot. We'll start from the planets from the next episode. Thank you so much for watching. Actually, I'm feeling a little bit ill now, so I'll stop the recording here. We'll continue the planets from the next episode. Thank you so much. Please subscribe if you have not subscribed at all. Do like this video and share with your friends. Have a nice day.